Hello, so we're going to go over epithelial tissue. I wanted to show you guys slides showing lower magnification and also higher magnification. So the magnification is shown here in the corner. This is at 100, and this is at 400. So if we go back to 100, here, these are the renal corpuscles, and we'll get to that when I cover the urinary system. But I want to go ahead and I want to show you guys, if you see here, these where the shape looks a lot rounder, and you can see this lumen highlighted in yellow, this is going to be the cuboidal epithelium. Because remember, we talked about how cuboidal epithelium surrounds ducts, D-U-C-T. So because of that, you tend to have this lumen, this opening. So as we're looking here, the simple squamous is lining this renal corpuscle. You see these flat cells? Because remember, we said these don't exist in a vacuum. Okay, the cuboidal cells and the simple squamous can sometimes be in the same environment. So here, highlighted in yellow, you see these thin flat cells. But then when you go over here, I'm just going to outline it with the mouse. See? You can see that you have these cube-like cells. So they're not complete cubes, like perfect cubes, I mean, but you see they're cube-like. And also what lets you know that you're looking at a cube, that you're looking at simple cuboidal, is going to be this opening here, because they tend to form circles. You see that? Okay, so moving on. Here, you can see even closer the simple squamous. So see, it's highlighted here in yellow. Flat cell, flat cell, flat cell, flat cell, going all the way around. And then over here you can see some more of the cuboidal. So cuboidal tends to have the same width as the height. So almost a perfect square. The squamous are going to be the flat scale-like cells. Flat scale-like cells. Okay? And this is at 1,000 times magnification. More of the simple squamous. See how flat that is? The nucleus is flat and elongated. If we go back, when we looked at the nucleus of our cuboidal, it's much rounder. And you also see less space around the nucleus. So when we get to the columnar, I want you to pay attention to that space, because this space here is going to change. You're going to see a lot more of the pink area, but right now the nucleus is almost taking up the, well, it's taking up the majority of the cell. Okay? Over here we see more of the simple squamous cells here. And we'll zoom in here. More simple cuboidal. Look at that. Have this opening here in the middle. And you see the nucleus is taking up most of the cell. It's one layer, so this is simple cuboidal. More of the simple cuboidal. And also, so here highlighted in yellow, there's the simple cuboidal. And then here, this thin layer of cells surrounding it, that would be the simple, this here, you have some simple squamous. You have the basement membrane shown here. And the nuclei shown here. And you also see that the nucleus is taking up the majority of the cell. You have a nice round nucleus, whereas with the squamous you saw a flat cell, a flat cell with a flat nucleus. Just showing you a lot more examples of the simple cuboidal to really drive the point home. And this is in the pancreas. So as far as the places where you expect to see the simple cuboidal epithelium, kidney tubules is a big place. Secretory, the secretory areas of small glands, the ovary surface are some of the places we expect to see cuboidal. So now let's look at the columnar. Remember I said to pay attention to that nucleus, because once we get to the columnar epithelium, you're going to notice a big difference. So highlighted here, we can see the simple columnar, and we'll zoom in. Do we see those columns? You see how you can see a lot more of the cytoplasm around the nucleus. The nucleus isn't taking up so much of the cells making up this tissue. Here is another example of simple columnar. Here on top you see where it looks like there's like yellow hair at the top. That is the microvilli. Now the microvilli is not the same as the cilia. The microvilli is designed for absorption. So some of the places, or one of a major place you would definitely expect to see the simple columnar is in the small intestine. You could see it actually line most of the digestive tract. Going from stomach to rectum, you will see a lot of simple columnar epithelium. Okay, so, and these goblet cells here are for secreting mucus. So this is the basement membrane. So that's the quote-unquote bottom, and this is the apical surface here. And then, hold on, let me get that. And then you see the microvilli here at the top. But look at the nucleus. Look at the nuclei, okay? You see how the nucleus is arranged? They're bigger, they're more elongated, they're not as like plump and round as those that were in the cuboidal epithelium. So you can see the heights are different. Columnar epithelium is taller than it is wide. Here we see more of the simple columnar, that elongated nucleus. You see a lot more of the cytoplasm around the cell, and those are a few more goblet cells, and again their job is mucus secretion. Here we are at lower magnification, and you're looking at the pseudo stratified columnar epithelium. Okay, and we're going to zoom in. So, with the pseudo stratified, look at the nuclei. Look at the nuclei. You see how because some of the cells are tall and some are shorter, it gives the appearance that this is stratified, but it's not stratified. Just some of the cells are taller than the others. Okay? On atop this, we can see cilia. Okay, so we said cilia is different than the microvilli. Microvilli is designed for absorption. The cilia is designed to move particles along, specifically to move mucus along, because we don't want mucus to get stagnant. Okay, so here's the basement membrane. So this is the quote-unquote bottom, and then up here, this is going to be the apical surface, and we see the microvilli. And see, we said that, you know, the tissues don't exist in a vacuum. Down here, it looks like we have some cuboidal epithelium. Okay? Here's a close-up of pseudostratified columnar, and you can definitely see the different heights of the cells making up this tissue. Look, the nuclei are all over the place, and it gives the appearance of it being stratified, but it's not. It's just that the cells themselves, some are taller and some are shorter, and we see goblet cells present again, so that has to do with the secretion of mucus. Okay, and then you have this cilia atop here, and the cilia's job is going to be to move that mucus along. More of the pseudostratified. Now we're going to look at the stratified squamous. Again, the squamous cells are flat and scale-like, okay? So we've so far seen just this, the simple squamous. Simple, again, meaning one layer. Stratified, meaning multi-layered. Here we are at 40 times magnification. And this is the vagina, so this is going to be thin skin. Here we are at 100 times magnification. This is the stratified squamous epithelium. Here, this is the epidermis. So look, you see all of these very, very flat cells. Look at the very tiny nuclei. They're all stacked on top of each other. This definitely looks nothing like the cubes. This looks nothing like the columns. Looks nothing like the pseudostratified. This is definitely stratified squamous. We'll go even bigger. Here we go. We're at 400 times magnification. Now you can really see these flat cells. Very, very flat cells, okay? And they, again, look nothing like our cubes. They look nothing like our columns, just flat cells stacked on top of each other. And this is more of the stratified squamous. Stratified squamous, the flat scale-like cells. So you'll notice there's another layer here. We see this looks like a almost like purple waves here. And you notice that at this top layer there are no nuclei. That's because you're looking at a layer of keratin. Okay, keratin again being the protein that adds in waterproofing the skin. So you'll look here at the label, this is thick skin. The vagina is thin skin. So thick skin again is found on the palms of the hands and the soles of the feet. So let's go back and we're going to look. You'll notice there's an absence of a keratinized layer. See up here? You don't see the purple waves. And then we go here and you see these purple waves, these anucleated purple waves. So you'll look here in this layer, here, you see that there are these dark purple dots. That's the nuclei, okay? So if you look up here, it's definitely not the same thing. Up here, there's no nucleus, so this is not cells we're looking at protein. So one more time, we'll go backwards. Look at all of the purple dots. So those are that's nuclei. So these are cells. This is alive, quote unquote. So this is thin skin. Then over here, one more time, this is thick skin with this nice thick layer of keratin on top that adds in protection and waterproofing and structure. Okay. Keratin is a protein. Over here, we see some more stratified squamous epithelium. This is keratinized too. Look here, you can see that layer at the top. Up here, you see a layer of keratin there at the top. And here, we're just looking at some more cuboidal epithelium. This is just stratified. Stratified again being multi-layered. So there's one layer and then there's another layer here. Okay, so this is definitely stratified. And this is in the sweat glands. Transitional epithelium, we're on lower magnification here. So the arrangement of the transitional epithelium, you'll notice that, as I said in class, this looks like a dog pile of cells, essentially. Some of the cells seem more square, more rectangular. They're laying on top of each other. And that's because they're designed to stretch out. They're designed for distension. Okay, you see these umbrella cells sitting up here. And this is a telltale sign that you're looking at transitional epithelium, and you find this in the urinary bladder, and this this tissue pattern is very, very effective for distension. Again, looking at transitional epithelium here, and even on much higher magnification, you can see here, look at the shape of the cells. These seem to go much more horizontally. Then you have these square, more square-looking cells. So basically you have a lot of different cell types. And again, they look almost like a quote-unquote dog pile. So I hope that helps, so that, I know this is the basement membrane here, so that you kind of get your orientation. This is the apical surface, and this is the basement membrane. So hopefully that helps just to give you a little bit more info on the epithelial tissue. I'll post another one on connective tissue shortly. Thank you.